Okay, continuing with problem number 4. Let's see, we're going to solve a rational equation. We need to get rid of that fraction. Since both of the denominators are just x minus 6, we can just multiply straight through every term by x minus 6, not just the fractions. Even the 9 has to be multiplied by x minus 6. So we would have 6x equals 9x minus 54, and then plus 7x squared. Now, I'm going to write this in standard form so I can factor it or use the quadratic formula. So I need a 0 on one side. Since the x squared is on the right and the coefficient is positive, I'm going to go ahead and get the 0 over on the left by subtracting 6x. But I'm going to write it with the x squared first. 9x minus 6x would be 3x and a minus 54. So thinking of the numbers that multiply together to give us 7, there's not a lot, just 1 times 7. Numbers that multiply together to give us 54, well, there's more. 1 times 54, 2 times 27. Let's see, 3 times what? Is it 3 times 18? 4 doesn't divide into 54. 6 does. 6 times 9. Is that about it, you think? Running sort of out of room, so I'll just do it over here. There's not a lot of possibilities for the 7x squared, so I'll just write the x and 7x. Now the second sign is minus, so that means there should be a plus and a minus. And then it's a matter of figuring out which pair of numbers is going to work. If I put a 6 or a 9 here, I'm going to get a mighty large number. 21, if I put, no, 42 and 9. Trying to get things that will subtract to give me a 3 when I plug them in here and FOIL it out. I'm thinking it's going to be 3 and 18. If I put a 3 here and an 18 there, I'd have a 21x and an 18x. I can sure subtract those and get a 3. So how do I arrange my plus and my minus? Well, if I want the 3x to be positive, I think this is how we're going to have to do it. We'd have a positive 21x minus 18x. That's giving me a 3x. So set each one of these factors to 0. And we get x equals negative 3. And what about right here? 7x minus 18 equals 0. I move the 18 over and divide both sides by 7. Oh, I'm running out of room. So negative 3 and positive 18 over 7. Negative 3 and positive 18 over 7. Notice if we had gotten 6 as an answer, we would have to mark it out because that would give us a denominator of 0. So negative 3, comma, 18 over 7. So question number 5. Solve this inequality. How do I know it's an inequality? Well, there's a greater than sign on it. It's number 5. If you see a greater than or a less than sign, the method that you use for solving is the cut point method. X squared plus 7x minus 24 is greater than or equal to x minus 8. Well, to find the solution cut points, you put an equal sign in place of the greater than or equal. And we now have an equation that we know how to solve this. It's a quadratic equation. So I'm going to get an x and factor. So I'm subtracting x. So we have x squared. 7x minus 1x is 6x. Negative 24 plus 8, negative 16, equals 0. Let's see. This is a simple. Oh, look at that. Yeah, sorry about that. Okay, so the solution cut points are found by replacing the inequality with an equal sign. So to solve a quadratic equation, I just get a 0 on one side. Let's see. This is a simple trinomial because you just put x and x. So it's easier to figure out which pair of numbers work. 1 times 16, 2 times 8, or 4 times 4. Since the second sign is minus, we have 1 plus, 1 minus. It's going to be 2 and 8, right? Those are the numbers that multiply, that subtract to give us 6 and multiply to give us 16. Now to get a negative 16, we need a positive and a negative. I think the 8's going to have to be the one that's positive, and the 2 negative, if you FOIL it out, that should get that positive 6x squared. Now set each one of these factors to 0, and we get x equals 2. And over here, moving that 8 and negative 8. There's no denominator cut points because there's no fractions. So I'm going to locate negative 8 and 2 on my number line. And I should have already asked this. Open or close circle at the solution cut point. Well, since we have an equal sign on there, it's a closed circle. And there were no repeated factors, so it's going to alternate. I'll just choose a number between negative 8 and 2 and plug it in. I'm going to choose 0. 0 lies between negative 8 and 2. So if I test 0, you'd have 0 squared plus 7 times 0 minus 24 is greater than or equal to 0 minus 8. So negative 24 is greater than or equal to negative 8. Don't say true. This is false. Remember, the more negative it is, looks like I just put a decimal point there. So let me do that there. So false. Negative 8 is bigger than negative 24. You'd rather have negative $8 in your bank account than negative 24. So the answer in interval notation, parentheses, negative infinity to negative 8, square bracket, union bracket, 2 to infinity. Let me type that in. Parentheses, negative infinity, comma, negative 8, square bracket, union, bracket, 2, comma, oops, I hit the wrong thing, infinity, always put infinity, parentheses at infinity symbols. Okay, let's Go on to the next problem. Another inequality, but this time we're going to have some domain or denominator cut points, aren't we? Problem 6. X minus 15 over x minus 16 is greater than 3. Pardon? I'll begin by finding the solution cut point. I'll replace the greater than symbol with an equal sign. So for solution cut point, x minus 15 over x minus 6 equals 3. I'll think of that as 3 over 1 and just cross multiply. So 3x minus 18 equals x minus 15. To solve this linear equation, I'll just isolate the x. I will move the x over, subtracting x. 3x minus x is 2x. Negative 15 plus 18 is 3. Divide both sides by 2. So my solution cut point 3/2 has what? An open or a closed circle on it. Well, since there's not an equal sign here, it has an open circle. Now our denominator cut point. The denominator of a fraction can never be 0. So x can't be 6. Denominator cut points are always open circle because you don't want to include those as solutions. So draw a number line. And let's label. Be sure to label these numbers in numerical order. A positive 3/2 is to the left of a positive 6. Now, I'm going to test 0. There were no repeated factors, no factoring at all there, so it's alternating. Let's test 0. 0 lies between a negative and a positive. 0 minus 15 is a negative 15. 0 minus 6 is a negative 6. Negative over negative is positive. 15 over 6, that's going to be 2 1/2. Negative 15 over 6, you can think of it as dividing above and below by 3. 5 over 2, it'd be 2 1/2 is greater than 3. False. So true. False. So our answer in interval notation, parentheses, 3/2, comma, 6. Close parentheses. Let me touch that number in. Or that answer, I should say. Parentheses, 3/2, right arrow, comma, 6, close parentheses. Enter. Oh no, what did I do wrong? 3/2, comma, 6. Well, you know what? I just noticed I miscopied this problem. It's x minus 16, not x minus 6. Okay, well, I'll just, let me make a note on here. I miscopied this problem. You go flip the page, and I'll see, look at what happened. I should have been more careful. I miscopied the problem, didn't I? That should have been a 16. So I'm going to do it all over again. And pull up the problem. I'm going to do it correct this time. Number 6. X minus 15 over x minus 16 is greater than 3. Again, this answer here is wrong. Okay. Let me check once more. X minus 15 over x minus 16 is greater than 3. Okay. Solution cut point. Replace the inequality with an equal sign. I'll think of it as 3 over 1. And we have 3x minus 48 equals x minus 15. Basically, it's exactly what I did a while ago, just it's a 48 here instead of an 18. So we have 3x minus 1x, it's a 2x, negative 48, moving it over, we'd be adding 48, so 48 minus 15, is that a 33? Divide by 2 to get 33 over 2. This solution cut point still has an open circle. There's no equal on it. The denominator cut point, x minus 16 can't be 0. X can't be 16. Always an open circle at the denominator cut point. Now, okay, 33 over 2. What would that be as a decimal value? Let's see, 33 over 2. Is that 16 and a half? Fetch that into your calculator if you doubt that it's 16 and a half. So we have a 16 and a 16 and a half. Both of those are our cut points with open circles. Testing 0. 0 always lies between a negative and a positive. So 0 minus 15 over 0 minus 16. Well, 15 over negative 15 over negative 16, that would be a positive 15 over 16. That fraction is certainly not bigger than 3. False. True. False. So our answer is parentheses 16, comma, 33 over 2. Comma 33 over 2. Okay. Number 7. Find the center radius form of the equation of a circle. So we're going to find the center radius form of the circle with the center at 4, negative 2, and the radius of 5. To write the center radius form of the equation of a circle. Oops. You have to know that center, which we call HK, and the radius. So the equation of a circle, x minus h squared plus y minus k squared equals r squared. Now be careful. You're replacing the h with a 4. You're replacing the k with a -2. Now that's going to be the tricky part. Replace the r with a 5. So x minus 4 squared plus y minus a -2. Y minus a -2 would be a +2 squared equals 5 squared. Don't say 10. That 5 squared is 25. So x minus 4 squared plus y plus 2 squared equals 25. Let me punch that in. X minus 4 squared, right arrow, plus y plus 2 squared right arrow equals 25. Okay. And now we're going to graph it. Well, in order to graph a circle, all you need to know is that center and radius. If you were using doing paper and pencil with a compass, you'd put the the sharp end of the compass on the center and then move over 5 units. That's what we're going to do here. I'm going to say graph a circle. So the first thing we're told to do is plot the radius. The radius is 4, -2, so that's right 4, down 2. I look in the yellow rectangle and I'm on the right place. I'm at the right point. And now move over 5 units. I think I'll move up 5. 1, 2, 3, 4, 5. When I moved up 5, I also moved right, left, and down 5 also. Now number 8. Find the center and the radius of the circle with the given equation, then draw the graph. Number 8. X squared plus y squared plus 8x minus 2y equals 19. Squared plus y squared. I'm checking to make sure I didn't miscopy it. I've already messed up once because I miscopied a problem. So a wise man learns from his mistakes. Well, we know how to find the center and radius when it's written in this center radius form with the parentheses. Just change the sign square root. So we're going to use completing the square in order to get our equation written like this. You start off by grouping the x terms together. Then I'll put just a plus blank. I'm going to fill that in a moment. Then we'll put in the y terms, y squared minus 2y plus blank equals 19. we're going to fill in each of these blanks with numbers, and whatever number we add to the left, we got to add to the right. In fact, the numbers we're going to add are going to be perfect squares. In order to figure out the number that goes here in the red blank, you take half of this number and then square it. Take half and then square it. Half of 8 is 4. 4 squared, 16. Half of 2 is 1. 1 squared is 1. Notice I'm not worrying too much about the negative. If you want to say half of negative 2 is negative 1, negative 1 squared is still 1. Now here comes the crucial part when we're going to factor these as perfect square trinomials. This variable, that sign, half of that number. X plus 4 times x plus 4, if you FOIL it out, will give you x squared plus 8x plus 16. Doing the same thing with the y's. Y, that next sign, half of 2. And what number do we have on the right? 36 plus, I said the answer. 16 plus 19 is 35 plus 1, 36. Now that it's in this form, all you got to do is change the sign, square root. So the center, change the sign. The center is negative 4, positive 1. The radius, square root, is a 6. So, type in that answer in. Oh, wait, we don't type it in. We're just told to graph it. Well, to graph it, you plot that center. Oh, let me do this. Circle. Let's plot the center. Left 4, up 1. Oh, that's up 2. Oh, each little mark is half. Now I'm at left 4, up 1. Now I'm going to move up, down, left to right 6 units. Well, if I started at left 4, up 1 and moved up 6, I'd be at left 4, up 7. Be careful. And now we can check it. Okay. Only way you can graph a circle is if you know that center and radius. Find the domain of the following function. Let me write this. Find the domain of 1 over x squared minus 2x minus 8. And we want this domain stated in interval notation. That's with the parentheses and infinities and so forth. Well, the domain, that's the set of numbers you can plug in for x. Well, here you can plug anything for x as long as you don't get a denominator as 0. The bottom of a fraction can never be 0. So let's just solve this quadratic inequality as if it were an equation. Let's factor it. How would I factor this thing? We'd go x and x, either 1 times 8 or 2 times 4. I'm thinking it's 2 times 4. The second sign is negative. That means we need a plus and a minus. How should I arrange it I need them to multiply together to give -8 and add together to give a -2. I think that does it. We'd have for outer and inner, -4x plus 2x, that's a -2x. Now set each one of these to 0. And we get that x can't be -2, and it can't be +4. Now, those are the numbers that x can't be. We want to write out all the numbers that it can be. If you were just writing this out in words, you'd say the domain is all real numbers except -2 and 4. Well, unfortunately, we don't write it out in words. We write it out in interval notation, and open circles mean not included. To say everything from -infinity to infinity, excluding -2 and +4, interval notation would look like this. Parentheses, -infinity, comma, -2, parentheses, union, parentheses, -2 to 4, parentheses, 4 to infinity. That's just a fancy way of saying all numbers except -2 and +4. Remember, open circles and parentheses mean not including. -infinity, comma, -2, close parentheses, union, parentheses, -2, comma, 4, close parentheses, union, parentheses, 4, comma, infinity, close parentheses. Check my answer. Okay? Oh, find the domain of this function. Well, we can't have a 0 in the bottom of a fraction. And under a square root, we can't have a negative. It's okay to have a 0 under a square root. You just can't have a 0 in the bottom of a fraction. Okay? Have you put up your calculator? Oh, where's my calculator? Where did I put it? Oh, it's can't have a 0 in the bottom of a fraction, like 1 over 0. It gives you an error warning. Similarly, if you had a 0 under a square root, that's fine. Second square root 0 gives you an answer 0. But you can't have a negative under the square root. Like we know that the square root of -25 is 5i, but not here. This calculator works only with real numbers. Okay? So to find the domain, we're going to solve the inequality. 50 minus 5x must be greater than or equal to 0. That's just going to be a real easy cut point problem. What we were doing over here with the cut points. Except it's much faster. To find the solution cut point, you just say 50 minus 5x equals 0. I think I'll move the 5x over. And then divide by 5. That's the fastest way to isolate x. Now there's no denominator cut points. There's just no denominators here. But this solution cut point, because of the equal sign there, it's going to have a closed circle. So I draw my number line, label the number 10 with an with a closed circle, and then test the interval. If I wanted to test 0, that would be here between a negative and a positive. If I put a 0 right in here for x, we have 50 minus 0 is greater than or equal to 0. That's true. So parentheses, negative infinity to 10, square bracket. Let me move my little calculator out of the way. Parentheses, negative infinity, comma, 10, square bracket. Oh, it's just spinning and spinning. I wonder if I've lost the internet. Well, it's still spinning and spinning. So this is a good place to stop. And I'll take a little break and check on my internet.